Okay, this video is on lines and transversals, and we're going to start out by reviewing some things that we've already talked about. Linear pair angles, remember, are just angles that are adjacent and supplementary. Vertical angles are two non-adjacent angles. That are formed by a pair of intersecting lines. And the vertical angles conjecture we've talked about just says vertical angles are congruent. Now, I want to make another conjecture that I'm going to call the intersecting lines conjecture. And my intersecting lines conjecture, here I've got a pair of intersecting lines, and I've labeled, notice I've labeled these four angles here. I'm gonna make this conjecture about intersecting lines. I'm gonna say if two lines intersect, then every pair of angles formed is either congruent or supplementary. Now, the reason I'm pretty sure that this statement is true, notice I haven't proved it, it's just a conjecture. But I'm pretty sure that it's true because I noticed that if I have two intersecting lines here, I've got these four angles. And any pair of angles that I choose, they're either going to be vertical angles, like for example, angle 2 and 4 are vertical angles, and angle 1 and 3 are vertical angles. Or they're going to be a linear pair of angles, like 3 and 4, 1 and 4, 1 and 2. And I already know that linear pair angles are supplementary. And I've got a conjecture in which I'm pretty sure that vertical angles are congruent. So any pair of angles, since every pair of angles is either vertical angles or linear pair angles, they're either going to be congruent or supplementary. So I could actually write down, let me write down here my congruent angles, name my congruent angles, my pairs of congruent angles and my pairs of supplementary angles. So let's see, my congruent angles are going to be all my pairs of vertical angles. So let's see, angle 2 and 4, those are going to be congruent. Angles 1 and 3, angle 1 and angle 3. So that's my pairs of congruent angles. My pairs of supplementary angles, so let's see, angles 1 and 4 are supplementary. Angles 1 and 2 are supplementary. Angles 2 and 3 are supplementary. And angles 3 and 4 are supplementary. Okay. Now we're going to talk some about lines and transversals. So let me draw two lines here. Let me call this line L, and I'll call this line M. And I want to talk about some areas here on this diagram I've got. The space that I'm going to call the interior of these two lines. This is just the space inside the two lines. All right, inside meaning interior. So if I put, for example, let me just mark some X's in here. Everywhere those X's are, that's the interior of these two lines. The exterior of the two lines, that's just going to be the space outside the two lines. And let me put some boxes. All these boxes here are exterior to the two lines. They lie outside the two lines. Outside means exterior, means outside. All right, now I want to define this thing called a transversal. And a transversal is just a line, all right, it's a particular type of line, a line that intersects two or more lines. So here I have these two lines, L and M, and if I draw another line that intersects both of these lines, let me call this line T. Well, line T is a transversal because it's intersecting these two other lines. All right. Now, notice that when I draw this transversal, I've created some angles here. In fact, let me go ahead and label these angles. 1, 2, 3, 4, 5, 6, 7, and 8. So I've got these 8 angles that are formed when this transversal intersects these two lines. And I can, based on my definitions here of the interior, the space inside the two lines, and the exterior, the space outside the lines, I can identify the interior angles and the exterior angles on this diagram. So my interior angles are just going to be the angles that are interior to the two lines. So let's see. The angles that are interior, my interior is this space right here, so I've got angles 3 and 4 and 5 and 6 are inside those lines, so angle 3, angle 4, angle 5, and angle 6 are my interior angles. I can also identify my exterior angles. My exterior angles are just going to be the angles outside the two lines, so that's going to be angles 1 and 2 and angles 7 and 8. Now, we want to take these concepts of interior angles and exterior angles, and we want to go ahead and identify some more angles, in particular some angle pairs. So let me kind of redraw this diagram that we just had here. My two lines cut by a transversal, and let me renumber these angles. Number them the same way I had them before. 1, 2, 3, 4, 5, 6, 7, and 8. So I've labeled these 8 angles. I've got my two lines cut by a transversal. Well, before we identified all the interior angles and all the exterior angles. Those were just individual angles. Now we want to talk about some particular pairs of angles that are going to be important in the upcoming units. So the first type of angles that we want to talk about are called same-side interior angles. Now, same-side interior angles have 3 characteristics. And the first one has to do with this description here. They're same side. The first characteristic is that they are on the same side of the transversal. The second characteristic, they are interior to the two lines. And the third characteristic is same-side interior angles do not form a linear pair. Okay, so now we have a definition of same-side interior angles based on these 3 characteristics. Let's see if we can identify the same-side interior angles, that is the pairs of same-side interior angles in this diagram. So they're on the same side of the transversal. So here's my transversal. Let's look at the left side of the transversal first. They're going to be interior to the two lines. That's these angles right here. Do not form a linear pair. So angle 3 and angle 5 would be a pair of same side interior angles. Same side of the transversal, inside the two lines, interior to the two lines, and they do not form a linear pair. So that's one pair of same side interior angles. If we look at the right side of the transversal, I've got angles 4 and 6. They are on the same side of the transversal, the right side. They are interior to the two lines, and they do not form a linear pair. So these are my pairs of same side interior angles for this diagram. All right, let's take a look at same side exterior angles. Well, these are going to be similar to same side interior angles in that they are going to be pairs of angles that are on the same side of the transversal. This time, however, they're going to be exterior to the two lines. And once again, they do not form a linear pair. All right, let's see if we can identify the same side exterior angles in this picture. They need to be on the same side of the transversal. Okay, so let's start with the left side. They need to be exterior to the two lines. So angle 1 and angle 7 are on the same side of the transversal, and they are exterior to these two lines. So that's one pair of same side exterior angles. If we look at the other side of the transversal now, the right side, angle 2 and angle 8, they are exterior to the two lines, and they are on the same side of the transversal. So angle 2 and angle 8 are the other pair of same side exterior angles. Okay, alternate interior angles. Alternate interior angles are angles that are on alternate sides of the transversal. Alternate just means opposite sides. They are interior to the two lines. And once again, do not form a linear pair. Okay, so let's see. Alternate interior angles. So I need angles that are on alternate or opposite sides of the transversal. So I need one angle on this side and one angle on this side. Interior to the two lines. So inside the two lines, that's these angles right here. And that do not form a linear pair. So that's going to be, for example, angles 3 and 6 would be alternate interior angles. Alternate sides of the transversal, interior to the two lines, and do not form a linear pair. Notice angles 3 and 4, they would not be alternate interior angles because angles 3 and 4 form a linear pair. So I've got one more pair of alternate interior angles. That's going to be angles 4 and 5. They are alternate interior angles as well. All right, alternate exterior angles. Once again, they are on alternate sides of the transversal. They are exterior to the two lines. And do not form a linear pair. All right, so let's see if we can identify the alternate exterior angles. Okay, alternate sides of the transversal, one on the left, one on the right. Exterior to the two lines. Okay, so I need my exterior angles here are 1 and 2 and 7 and 8. So let's see, angle 1 and angle 8 would be one example of a pair of alternate exterior angles. I've got angle 1 and angle 8. They are on alternate sides of the transversal. They are exterior to the two lines, and they do not form a linear pair. Notice once again, angles 1 and angle 2, they would not be alternate exterior angles because even though I've got one on each side of the transversal, and they are exterior to the two lines, angles 1 and 2 form a linear pair. So 1 and 8 are alternate exterior angles, and 2 and 7 are also alternate exterior angles. Okay, finally, our last pair of angles where we have two lines cut by a transversal are going to be corresponding angles. Corresponding angles, they have three characteristics. Corresponding angles are on the same side of the transversal. And for corresponding angles, we have one interior angle and one exterior angle. And once again, as before, they do not form a linear pair. Okay, so corresponding angles are often a little more difficult for students to identify. So let's take a look at these. Corresponding angles. They're on the same side of the transversal. Okay, so let's look at angles on the left side of the transversal. One interior and one exterior. So angle 1, let's see, same side of the transversal. Here's angle 1, an exterior angle, and here's angle 5, an interior angle. And they don't form a linear pair. So angle 1 and angle 5 would be a pair of corresponding angles. Notice angle 3 and angle 7, they're on the same side of the transversal. One interior, one exterior, and they don't form a linear pair. So angle 3 and angle 7 are also corresponding angles. Notice angle 1 and angle 3, they're on the same side of the transversal. One is interior and one is exterior. However, angle 1 and 3 form a linear pair. So angle 1 and angle 3 are not a pair of corresponding angles. Now, that's only on the left-hand side of the transversal. Let's look at the other side of the transversal. Angles 2 and 6 form a pair of corresponding angles, and angles 4 and 8 also form a pair of corresponding angles. And you notice the corresponding angles, that's the only type of angle pair for this diagram that you actually have 4 pairs of angles. All the others only have 2 pairs of angles. Okay, let's take a look at a couple of examples here. On the last page of your notes, it says, name each angle pair and the transversal used. So here you've got a diagram that's slightly more complicated than the one that we've been working with because we have a total of 4 lines. All the other diagrams, we just had 3 lines. So I've got line R and T and L and M. And I'm asked to name, for these examples 1 through 7, name each angle pair and the transversal used. Okay, so example number 1, angle 6 and angle 14. So let's see. Here's angle 6, and here's angle 14. We'll use a different color. Here's angle 6, and here's angle 14. Now, I noticed that for angle 6 and angle 14, this whole piece of the diagram doesn't really come into play. In fact, I could just completely cover this up, and if I do, now I've got 2 lines cut by a transversal, and it looks like the other diagram that I was working with. So for these 2 angles here, angle 6 and angle 14, I notice that they are on the same side of the transversal. My transversal in this case is going to be the line that intersects the other 2 lines. So that's T. My transversal is going to be T. Both of these angles are on the same side of the transversal. I've got one interior and one exterior. They don't form a linear pair, so these must be corresponding angles. And once again, my transversal in this case is line T because that's the line that is intersecting these 2 lines. So line T is my transversal. Example number 2, angles 4 and 7. So let me see. Here's angle 4 and here's angle 7. And again, notice that for this pair of angles, I'm really not using this bottom part of my diagram at all. So I can just cover that up. And now, again, I have these 2 lines here that are being intersected by this line right here. So this line right here is going to be my transversal, line L. So I could go ahead and fill that in. Line L is my transversal. Now let me identify this angle pair. So let's see, here are my 2 lines, and these 2 angles are inside my two lines. So these are interior to my two lines. I notice they are on the same side of my transversal L, and they don't form a linear pair, so these must be same side interior angles. Same side interior angles. Now I'm going to leave the rest of the examples on this sheet for you to do on your own. Here's a tip: at least one of the angle pairs that you're given is not going to have a transversal at all. And I'm going to let you play with that and see if you can figure out which that applies to, and we will talk about these tomorrow in class.